So here's our second lesson for week 1. This lesson is on 1.3, squares and square roots. The learning target is to understand perfect squares and perfect cubes, and square roots and cube roots. And we're going to be using something that we learned in our last lesson, which is writing a number as the product of its prime factors. So, just like we have the opposite of multiplication is division, and the opposite of multiplication is division. The opposite of adding is subtracting. Okay? The opposite of squaring is the square root. So if we did 5 squared, what that means is 5 times 5, and the answer is 25. If we wanted to go in the opposite direction, we would take 25 and we'd do the square root, and the answer would be 5. Okay. Cubing is the same as squaring, but just with 3 instead of a 2. So the opposite of cubing is cube root. So if you have 2 to the 3, 2 times 2 times 2, that gives you 8. And the cube root of 8 gives you 2. So these are two opposite things to each other. We also need to look at some terminology. So we have 3 new words: the radical, the radicand, and the index. Okay. So the radical is this whole thing. Okay, this is called the radical. It's any number under a square sign, or under a root sign. Okay, this swoosh, this is the root. Okay, so this whole thing is the radical. This number underneath the root sign is the radicand. Okay, and this, I'm going to erase this. And this, well, in here there's no number, but there could be a number right here. That is the index. Okay, so if you have an empty index, it means square root 2. Okay, an empty index means root 2. Otherwise, it would be a number in this space. It could be 3, 4, 5, 6, 7, whatever, any number. Okay. So in this section, we're going to be determining square roots without a calculator. So we're going to be, and why are we doing this? We're doing this because this is a fundamental step that we're going to be using later in this chapter for something that's more complicated. Okay. So normally, if you wanted to find out what the square root of 1,296 was, you could just put that into your calculator and get an answer. Okay. So, but this is a way you can do that without using your calculator to break it down. And we're learning this because we're going to build on it later. All right. So if we want to find out what the square root of 1,296 is, the first thing we need to do is we need to factor this and write it as it's a product of its prime factor. So we're going to be doing more factoring. So we're going to write out 1,296, and then I'm going to factor it any which way you like. Doesn't matter, but I like to use 2s, so that's what I'm going to do. I'm going to start off pulling out any 2s that I can. 2, I get 324, and then I get 164. I get 81. I get to 81. So I know that 81 is 9 times 9. So instead of removing a 3 or anything like that, I'm going to pull out my 9s. and I get 9 is 3 times 3, 3 times 3. Okay, so I'm going to highlight my prime numbers. So those are my prime numbers. Okay, so now what I'm going to do is I'm going to look for groups of number that are identical to the index. So remember, this says square root. That means that my index is 2. Okay, I'm doing the square root. So that little number, this little number here, my index with a square root is 2, root 2. Okay, so I'm looking for groupings of 2 identical numbers. I'm going to circle those. So I have 2 identical numbers here, 2 identical numbers here, 2 identical numbers, 2 identical numbers. Okay. Now I'm going to write each group with its exponents. So this is slightly different. Instead of counting up all the 2's, so 1, 2, 3, 4, and writing 2 to the 4, I am going to keep things in their circled groups. So I'm going to write 2 to the 2, okay, because I have 2 2's inside, inside this group I have 2 2's. So I'm going to write it as 2 to the 2 times 2 to the 2 times 3 to the 2 times 3 to the 2. Okay, so each of these groups has been simplified. So this group is represented here, this group is represented here, this group is represented here, and this group is represented here. Okay, now I'm doing a square root. So I'm going to take these and I'm going to write the square root sign on top because in the initial question it's saying it's a square root. Okay, I'm going to write the square root sign on top. Now, anytime that I have a square root and an exponent that is the same as the index. So remember here, when it's not written, the index is 2. Okay, so this index and this exponent match. When I have that match, I can cross them out. They cancel. So let me show you some other examples. So if I'm looking at a cube root and I have 3 to the 3, both the root and the exponent cancel and I'm just left with 3. If I had 4 to the, oh, this doesn't have to be a 4. Let's say this is, let's say this is 8 to the 4, like that. So again, this whole root and this would cancel and I'd be left with just 8. Okay. And then if I have nothing written in the index, so let's say I had 8 to the 2, the index and this would cancel and I'd be left with just 8 again. Okay, so here in this question, this is going to cancel and this and this and this and this. Those all match the index. So I'm going to be left with 2 times 2 times 3 times 3. Okay? So now I'm going to multiply those numbers together. I'm just going to rewrite them. Multiply together, and I get 36. And then, as a fourth step, I can check that in my calculator. So I can enter 1296. I can press the square root button, and I can check that I get 36 as a final answer. Okay, it's really easy to check your answer on these questions. So if you were doing this on a test, you would need to make sure you showed all this work and did these steps. And then you can also make sure your answer is actually correct by checking it on your calculator. Okay, so let's look at some examples here. So we have 196. So the first step, we have an empty index, so we know that means that it's a 2. Okay, so first we're going to factor 196. So we get 2 and 98. 2, and 49. And then 49, we can't divide that by 2, but it does divide by 7. And if you weren't sure, you would start with your lowest prime. You would start with 2. You'd try 2, it doesn't work. Then you would try 3. You do 49 divided by 3. Oh, that one doesn't work. You move up to your next largest prime, 5. You try 49 divided by 5, and you'd keep going, okay? Until you find one that worked. So this breaks down into 7 and 7. So remember with these questions, what I'm doing is I'm looking for identical numbers that match my index. So here I want identical pairs of 2. Okay. And I'm then going to write this pair is going to become 2 squared. And this pair is going to become 7 squared. So then I'm going to be taking the square root of that. So this is going to cancel, and this, and I'm left with 2 times 7, which is equal to 14. Okay, so my cube root of 196, my final answer is 14. So now we're going to do this next one, 576. So I have 2 and 288, 2 and 144, 2 and 72, 2 and 36, 2 and 18, oops, I'm running out of space, 2 and 9, 3 and 3. Okay, and what you're going to do is you're going, why don't you pause and try this one. So give it a try. I want you to find out the square root of 576 using this method. So give it a shot. Okay, so I'm assuming that you gave it a try. So now we're going to look for our identical pairs. So this index is 2. So we're going to look for pairs of 2. I'm going to write that. Oops. Each of these pairs is going to be represented with an exponent. This one. Okay. And then I'm going to square it. So I'm going to have the square root sign, and each of these will cancel. And I'll just get 2 times 2 times 2 times 3. And when I do that, I'm going to get a final answer of 24 when I multiply all those together. So my recommendation is that you now go to the homework, page 26, and you try numbers 1A to F in your homework. And then we're going to continue with the second part of this video.